In today's video, we will continue our discussion on the concept of unit cells. Okay, so today we will discuss about types of unit cells, or sometimes called as crystal systems. Types of crystal systems. Okay, in the previous class we classified unit cell as simple unit cell, body centered unit cell, and face centered unit cell, depending upon the position of the lattice point in the unit cell. In today's class, we will discuss about the classification of unit cell depending upon the shape of the unit cell, the size and shape of the unit cell. Remember, in all the examples that I had used in my previous class, I had always used a cubical unit cell, that is a unit cell having the shape of a cube. Okay, but it need not be the case always. So always we don't get a unit cell which has the shape of a cube. The unit cell can have shapes other than that of a cube. For example, a unit cell in a crystal may look something like this. Okay, or a unit cell in a crystal may look something like this, which are obviously not having cubical shapes. Okay, not having cubical shapes. Now, if you take any of these three-dimensional objects, you can characterize these objects in terms of 6 parameters. Okay, before that, uh, let me consider this cube again. Okay, you can take any other example. I will take the simple example of a cube. So I will select this as origin of this unit cell. Okay, you can select any of the 8 corners, but I will select this as the origin. Now you can imagine 3 axes. Okay, one is this direction, one is this direction, the other is this direction. Okay, passing through one of the corners of the cube. Conventionally, we take one of the axes as x-axis or a-axis, other as y-axis or b-axis, the third one as z-axis or c-axis. Okay, so we can imagine 3 axes passing through the origin, and these axes are called as crystallographic axis. Okay, crystallographic axis passing through the one of the edges of the unit cell. So here also you can have 3 crystallographic axes. Okay, 3 crystallographic axes. Here also you can have 3 directions like this. Now you can measure the length of the unit cell about these 3 directions. For example, the length of the unit cell along x-axis, let me call it as A. The length of the unit cell along y-axis, let me call it as B. And length of the unit cell along z-axis is called as C. Similarly, you can define the length of the unit cell here as A, B and C. Here also I can measure the length as A, B and C. Okay. Similarly, I can measure 3 angles. Angle between A and B, angle between A and B, or angle between B and C, or angle between A and C. Okay. Here also I can measure an angle between A and B. I can measure an angle between A and C, or I can measure an angle between B and C. These angles are denoted as alpha, beta and gamma. So altogether there are 6 parameters using which we can characterize or define the nature of the unit cell. The 6 parameters are 3 lengths A, B, C and 3 angles alpha, beta and gamma. Which is alpha, which is beta and which is gamma, we will come to know in a while. Okay, so the values of these 6 parameters decides the type of unit cell or type of crystal system. For example, we know that in a cube all the lengths are equal to each other, so A is equal to B is equal to C. Similarly, all the angles are equal to each other, that is alpha is equal to beta is equal to gamma, and all the angles should be equal to 90 degree. So this relation A is equal to B is equal to C and alpha is equal to beta is equal to gamma equal to 90 degree immediately implies that the unit cell is cubical in shape. Okay, if you look at the second example, okay, here we observe that two of the sides are having are having same length, that is A is equal to B but is not equal to C, and the angles, all the angles are equal to 90 degree. That is, if I select any two corners, the angle between the corners is 90 degree. Okay, so here A is equal to B but not equal to C. Two angles are equal to, all the angles are equal to 90 degree. Okay, so this is also somewhat different. Okay, here A, B and C appears to be equal to each other, but all the angles are not exactly equal to 90 degree. So depending on the relation between A, B and C, alpha, beta and gamma, we can have altogether 7 types of crystal system. Okay, what does it mean? If I take a substance or a compound, okay, and if I try to crystallize the compound and obtain it in the form of a crystal, the unit cell inside the crystal can be one among 7 types of unit cell. It cannot be any other type of unit cell other than the 7 which we are going to discuss. So please remember this number. There are 7 types of crystal systems. Okay, there are 7 types of crystal systems or unit cells. ಸೊ ಯಾವುದೇ ಕಂಪೌಂಡ್ ತಗೊಳ್ಳಿ, ಯಾವುದೇ ಸಬ್ಸ್ಟೆನ್ಸ್ ತಗೊಳ್ಳಿ, ಅದನ್ನು ಕ್ರಿಸ್ಟಲೈಸ್ ಮಾಡಿ ಅದರ ಕ್ರಿಸ್ಟಲ್ಸ್ ಅನ್ನು ನೀವು ಒಬ್ಟೇನ್ ಮಾಡಿದ್ರೆ ಆ ಕ್ರಿಸ್ಟಲ್ ಅಲ್ಲಿ ಇರುವಂತಹ ಯೂನಿಟ್ ಸೆಲ್ ಏನಿದೆ, ನಾವೀಗ ಡಿಸ್ಕಸ್ ಮಾಡುವಂತಹ 7 ಕ್ರಿಸ್ಟಲ್ ಸಿಸ್ಟಮ್ ಏನಿದೆ ಅದರಲ್ಲಿ ಒಂದರಲ್ಲಿ ಆಗಿರಬೇಕು. ಓಕೆ, ದಟ್ ಈಸ್ ದಿ ಮೀನಿಂಗ್ ಆಫ್ ದಿಸ್. ದೇರ್ ಕ್ಯಾನ್ ಬಿ ನಾಟ್ ಮೋರ್ ದೆನ್ 7 ಟೈಪ್ಸ್ ಆಫ್ crystal systems. Before discussing what are these 7 types of crystal system, let us define what is angle alpha, what is angle beta and what is angle gamma, which is called as alpha, beta, gamma. That is an easy way to remember which is alpha, which is beta, which is gamma. Now there are 3 sides A, B and C and 3 angles alpha, beta and gamma. Okay, now let me write the 3 sides here: A, B, C. Okay, and we have 3 angles alpha, beta and gamma. This alpha, symbol alpha, almost looks like A. Okay, the symbol alpha is almost similar and it has an appearance very similar to A. Okay, so we can relate alpha to A. Similarly, the symbol beta, okay, appears like, or it is very much similar to B. Okay, if I write capital B, it almost looks like beta, so we can relate beta, angle beta, to this side B. Of course, gamma does not look like C, but we have no other choice. We are left with no other option, so we can relate this gamma to this C. Okay, how these are related? For that, let me draw a circle. Before that, let me write these 3 sides A, B, C and join them through a circle. Okay, I have written A, B and C, which are the three lengths along x-axis, y-axis and z-axis, and I have joined them using a circle. Now opposite of A, I will write alpha, because alpha is related to A, right? Alpha is related to A. So opposite of A, I will write alpha. Similarly, beta is related to B. So opposite of B, here I will write beta. And finally, opposite of C, I will write gamma. Now it is very easy to understand. The angle between A and B is called as gamma, because gamma is written between A and B. Similarly, the angle between B and C is called as alpha, because alpha is written between B and C. Similarly, the angle between A and C is called as beta. Angle between A and C is called as beta, because beta is written between A and C. So by using this diagram, it is very easy to remember what is alpha, what is beta and what is gamma. Okay, so let me draw a unit cell which is not having a specific shape. Okay, it is having some shape, a three-dimensional unit cell. So by convention, I will take this as origin, this as the a-axis, this is the b-axis, and this is the c-axis. So length of the unit cell along x-axis is a, that is this length is a. Length of the unit cell along b-axis is b, and length of the unit cell, that is this length, along c-axis is c. Okay, what is alpha, what is beta and what is gamma? Alpha is the angle between B and C. So this angle is alpha. What is beta? Angle between A and C. Angle between A and C. This angle is beta. And what is gamma? Angle between A and B. So this angle between A and B is called as gamma. Okay, so this diagram explains what is A, what is B, what is C, and what is alpha, beta and gamma. So the values of these six parameters and the relation between these parameters A, B and C, alpha, beta and gamma, okay, gives a characteristic unit cell. Now let us understand what are the seven types of crystal systems that could possibly we get, and what is the relation between A, B and C and alpha, beta and gamma in each particular crystal system. Okay, so name of the crystal system and the relation between the parameters.